Well, hi there. Thanks for showing up for your learning. This will be the final video for the practice test. And we're going to be looking at this situation where you live in beautiful isolation, perhaps on the coast of the Atlantic, and the tides at your dock go in and out. Low tide happens this particular day at 3 a.m. The water is going to be 3 feet deep. And at 9 a.m., you're going to already be at high tide. Did you know that the tides go in and out twice a day? So I've rounded it to twice a day. It's actually every 24 hours and 50 minutes due to, I guess, the moon moving around the earth too. So it's not exactly every day. So, I mean, that's just very fascinating. But I rounded it to once every 12 hours. Here you have the gap between 3 a.m. and 9 a.m. being 6 hours. So the gap between high and low tide would be half of the period. So that would be, in this case, 6 hours. Rounded. Should be 6 hours and 12 and a half minutes, but we're not going there. All right, so this is high tide, 9 feet deep. So you could draw a diagram if you want. Here's your dock, okay? And then low tide is down here, and there's 3 feet of water. And high tide might be up here, and there's 9 feet of water. So what's the change? Well, the change is 6 feet difference, right? 6 feet difference. So let's go ahead and find the amplitude. Oh, wait, we want to know what we're looking for. Your friend's boat needs 4 feet of water, and they'd love to come visit you at 1 p.m. And you want to know, is that a good time for them to come or not? Particularly since they want to visit for a few hours. So let's see if we can resolve this problem. All right. So the amplitude is going to be equal to the maximum minus the minimum divided by 2. And in this case, here's the maximum, 9. Here's the minimum, 3. So that's 9 minus 3 divided by 2. That's 3. So the A amplitude is 3. The horizontal axis, C, is equal to the maximum plus the minimum divided by 2. So 9 plus 3. It's the average of those two divided by 2. So that is 6. That's the average height of the water, 6 feet. And how about K, the period? Well, that's trickier, right? You have to know that this is half of the period from 3 a.m. to 9 a.m. So 6 hours equals the period divided by 2. So if you multiply both sides by 2, then you get the period equals 12. All right, now we can find our K value. K equals 360 divided by the period, which is 12, and that's going to be K is equal to 30. All right, aren't you glad that I rounded to 12 hours instead of 12 hours and 25 minutes? You'd have a decimally K value, a K with a lot of decimal to it. So anyhow, here's K is 30, here's A is 3, here's C is 6. Let's solve for the phase shift. All right, so I make the questions, but I haven't solved this one yet, so I don't know what the phase shift is going to be. So let's set it up. We know that, what do we know? Oh, we know that the function that is the height of the water is a function of time, and it's equal to 3 multiplied by, we can choose sine or cosine. Let's choose sine. You could use cosine. Sine is fine. Sine of 30 multiplied by x minus d. We don't know d yet. We're going to find it. Plus c. C is 6. Cool. And then let's use this point to solve for d. We'll use a low tide, which happens at 3 a.m. and things are 3 feet deep. Cool. So in this model, 0 times 0 is midnight. Okay. Time 1 is 1 a.m. Okay, so x is measured in hours. That's going to be useful to us. Okay, so f at 3 is equal to 3, which is equal to 3 sine of 30 x minus d plus 6. Okay, subtract 6 from both sides gives you minus 3 equals 3 sine blah, blah, blah. 30, x is 3. So we should have substituted in for x there. Okay, so 30 times 3 minus d, okay, divide both sides by 3, gives you minus 1. And of course it does, because that's the minimum. Minus 1 is the minimum that sine can be. Once you strip away the c and the a, you're going to find your minimum is sine is minus 1. Okay. Minus 1 is equal to sine of 90 minus 30d. Okay. When is sine at a minimum? 270. So I can take, I could do this. I could take the inverse cosine, sine inverse of bracket that, and then let's go. Okay. It's going to tell me 270, or it might say negative 90, but I'm going to go with 270. Okay. So I have 1, but it's negative, and I want the inverse cosine of that. I don't know why I'm doing this. Negative 90. Just like I said, your calculator will tell you the same thing. Okay. So that's 270. I'm going to go with 2. Okay, let's use negative 90. Sure, fine. Doesn't matter. Doesn't matter which one you use. They're the same. So let's use negative 90 equals 90 minus 30d. Okay, subtract 90 from both sides gives you negative 180 equals negative 30d. So d is 6. Is it? Is that right? Yeah, so I guess it is. Yeah, d is 6. Oh, yeah, yes. Yes. So yes. Okay, good. Yes, I understand now. It's 6. I had some competing thoughts in my head there just for a moment. So now we know a function that we can use. We could graph a function. All right, let's go for it. So let's just go ahead. F of x is equal to 3 sine of 30 x minus 6 plus 6. Okay, cool. All right. And then we can go ahead and say, what will the tides be like at 1 p.m.? Note 1 p.m. and 1 a.m. are different, but since they're separated by 12 hours, they're actually the same. But we can go ahead and use 1 p.m. equals hour 13. Okay, because it's 13 on the 24-hour clock. It's 13 hours after whatnot. So we can go ahead and find the depth, right? We'll find the depth at that time, see if it's a good time for our friend to arrive. His boat needs, his or her or their boat needs 4 feet of water. So let's go. F at 13 equals 3 sine 30 times 13 minus 6 plus 6. Okay, 13 minus 6. So we now start our bedmas in here. 13 minus 6 by, no, it's not, 7. 7 times 30. 210. 210. Cool. F at 13, the depth at 13 hours, the depth at 1 p.m. is going to be 3 times sine 210 plus 6. Well, I got bad news for you. 210 is a negative value of sine, so it's going to be below 6. Let's see how much. The sine of 210, maybe you forget that it's negative 1/2, so you use a calculator. 210, but I take the sine of, oh, it's negative 1/2. All right, so negative half of 3, so that will be 3 times negative 1/2 plus 6. Oh, that's 4.5. So the water's high enough, they can come, right? Wrong. Why, Mr. Jennings? But there's enough water for them. They want to visit for a few hours, okay? Let's just forget that we had a function for that and graph this, okay? Here's our horizontal axis. 3. Oh wait, no, that's the minimum. It's the minimum amount of water right there. Here's the maximum amount of water. Okay? Here's the horizontal axis, 6. All right? Let's just plot the given points and we should be able to see it. Okay? Here, 3. It's at at 3 in the morning it was at a minimum. At 9 in the morning it was at a maximum. So those are there. Now use your period. So 3 plus 12 gives you 15. It's going to be another minimum at 3 p.m. and it's going to be another maximum at 9 p.m. So that's 15 and indeed 21 there. 9 plus 12 is 21. Very good, Mr. Jennings. All right, and then If we did like half of that, that's where it crosses like a quarter of the period. So every 3 hours, it's going to cross the midline. So from there to 6, it crosses the midline. And from there to there, it crosses the midline like that. Wait, no, every 3 hours. There, sorry. There, not that one. I'm going to erase that. Okay. So now we have enough and I actually also happen to know that those points are your 1/2 points. So they're actually like there and there. And these you could find algebraically if you want, but I happen to have a few tricks up my sleeve, as you've noticed, is there and there. And then we can also, put that one over there and that. Okay. And there. All right. So now we can get a pretty good graph of what's going on here. All right. And this is a pretty good graph. It's good enough. And I'll show you why we only need good enough for this question, because it's not actually requiring a high degree of accuracy. Oh, I should have been a little lower than that, but I'm not erasing, because our point of interest is over here at 13. This is what our friend says they wanted to visit. And notice that the water is at 4.5 high and the tide is going out. Okay. So their boat's only good if there's 4 feet of water. So they can't be at our place between that time and that time. So their visit can only last like 20 minutes. They got to hightail it out of there. That's no good. So why don't we ask them to arrive here? How about we tell them, no, it's not a good time because I'd like you to be able to stay for long enough that we can enjoy a cup of coffee together, relax and chat, maybe have a snack, maybe play a board game. And we won't have enough time to play a board game if you arrive at 1 p.m. So how about you arrive instead at 17 o'clock, which is also known as 5, and you can stay all evening, all the way till 9 at night. You could even stay until 1 in the morning. Then you got to get out of there. 1 in the morning, you got to get out of there. Okay? So come at 5. You could even stay as late as 1 in the morning. All right? So that would be just the solution here. All right? Now, how would you know that if you only did algebraic? Algebraic says it looks pretty good. There's enough water. And we see there is enough water to arrive, and like if they were just dropping off a package, that'd be fine, but they want to stay for a few hours. So how would you know that? Well, you could just use your knowledge of sine function, right? And know that at, here, I'm just going to pause that. Okay. So if you know from your sine function that we were looking at like a value of -1/2 was equal to y, and we found that that was at x is equal to 210. And notice that the water is going out at that time. The water level is going down. Okay, so if you only had 6 inches of water clearance and you were losing water, that's not a good recipe to have a long visit. Okay, you'd be much better waiting for that point, which of course in our graph happens over here. Oh, hello, kitty cat. All right, so that's this word problem. Oh, yeah, you want to see me write a sentence answer, don't you? Okay. I would tell my friend not to come at 1 p.m. because despite there be, got some spelling mistakes hidden under there. Despite there we go. There being 4.5 feet of water, the tide is going out, which would not allow us to have a nice long visit. Why not come at 5 p.m. instead? There, that's how I would answer that question. Great. So I hope that gives you some holiday cheer. And If you have any questions, hit me up by email. Okay, bye everyone.